Okay, first, let me apologize for this talk, which is not as scientifically interesting as the rest, because it's more about the production. I'm part of the production team of CARRA, and I'm in charge of producing the daily and from then monthly means for all the variables in the data set, and we call the CARRA timely updates, which is going to be available in CDS hopefully soon. So essentially calculating climate means, first daily means, and also daily accumulations for accumulated variables, and also mean and max variables. So there is a total. Can you see my? Oh. Okay, there we go. There's a delay. There's a total of about 85 parameters I'm processing for each domain, and there is about 11 model levels, high level 7. Oops. This is slower on the screen for some reason. That in my screen. So pressure levels, single or surface levels. We have around 22 instantaneous parameters from the analysis files and around 6 for the forecast. And then we also have like soil levels included as well. And it was an error to put this. So the data source is like we use mostly analysis files for all the instantaneous parameters, and of course forecast files for accumulated parameters. And there is some instantaneous which are only available in the forecast files, which is min or maximus variables, which temperature and wind. Of course, there is some parameters which are repeated in different types of levels. So coming out to the methodology, is just this will be described in this report, which will be available later on the Confluence side of ECWF. And we try to follow the same approach they do for ERA 5, the climate means. For the instantaneous parameters, we do the analysis fields 8 times a day. And for the min-max parameters, we use forecast fields, which we take the minimum or the maximum over the day, in this case. And for the accumulated quantities, we provide early sums that then they are used to calculate the monthly means. And the way we calculate this for the accumulated quantities is that cut and paste from the report above. We just take 3 accumulated periods based on forecasts which are longer than 6 hours. So we managed to avoid the spin-off effects, hopefully. And then we calculated the daily accumulations based on differences at 6 and 18 hours accumulation from forecast initiated at 00 and 12 UTC. Finally, the monthly means are based on the daily means or the daily sums for the instantaneous or the accumulated parameters. And for the minimum and maximum parameters, these parameters which are the minimum of something or the maximum of something, which is temperature or wind, we take the minimum of over the whole month for the whole for every grid point, and or the maximum in this case. So to summarize the methodology for the production of the climate means, mostly we use analysis fields and forecast fields in the case where the other are not available. And for cumulative variables, we use forecast fields. And for the daily accumulations, we use essentially this formula here based on the differences between the forecast initiated at 18 UTC the day before or at 0 and 12 UTC on the day. And finally, the monthly means are based on the daily means or the daily accumulations. So for the actual production, the data is not yet available in CDS. And the calculation, like as Semyon demonstrated this morning, can be easily done in Python, R, or CDO using the data extracted from CDS. But in the production, we use grid files, and then we use the grid mean tool written by Hans Herfeld and easy codes. So it's everything in grid format. And in the production, we start the data from Mars, and of course, in your case, you can also extract it using the CDS API. And in Mars allows you to do calculate these differences I described before directly in Mars. When using CDS, you can do this after extraction. And just to kind of include a bit of a tutorial how to do that here, I will show you how to do that in CDO. So you extract the data, say with CDS. You can calculate the differences between the files. Say you take the extraction for the day before at 12, and then the same at 12 and 00 UTC on the day, and then you can calculate the differences as explained here. The first difference based on the two files at the day before on the day, and you dump it in this file. And same for the second difference, and then for the third. And then finally, you can just add all together with, again, using CDO and some operator on the three previous output files, and then you get in one file. Finally, I also have a couple of examples similar to what Semyon showed this morning, and they're available in this GitHub repo. And just to show one of them, because the previous one is just how to download the data, similar to what Semyon showed this morning, how to download and extract the data from CDS. You can specify the domain you want. In this case, I just shows Greenland. And then, of course, you compare as usually with ERA 5. It's pretty much what Semyon showed this morning. But in my example, I included in a bit a couple of functions you can use to extract the data in grid format, in this case from CARRA, and how to plot it using different projections, like the original projection, and then more like a polar stereographic projection, or the lat long projection. So now, just to show a couple of example plots, the difference with ERA and ERA5 and CARRA. For example, this is the monthly total precipitation for the month of January 2013. And as many people have illustrated today, the level of detail of CARRA is a lot finer, and you can see big difference in the maximum amount on CARRA compared to ERA5. Here's just the same thing showing the pressure levels, which at large scale they look very similar, but there's more level of detail on the finer scale, as Morten illustrated this morning. Then again, a couple of these min-max temperature for the month. This is a minimum temperature after post-processing, has a very long name. And for CARRA, you see the minimum is is smaller than say for ERA 5, and then that's probably overland here gives you more detail with the higher resolution. And similarly for the maximum, again the minimum of the maximum is a bit lower in CARRA than in ERA 5 for the same month. Yeah, so that's essentially my brief summary on how the climate means are going to be produced. They will be delivering monthly means or max of means. And in for CARRA in CDS, and the daily means will be maybe included too. That's on the consideration. And as I said, the data is not available yet in CDS. And you can check out this sort of temporary repository where I included also the examples that Semyon showed this morning on how to use these scripts. And again, if we can also include other like utilities like calculating the means or the sums based on the grid files. So yeah, that's it for me.